Hello students, welcome back to my YouTube channel Rasayan. This is Indrani ma'am. In my last video under laws of chemical combinations, I explained law of conservation of mass. Today I am going to explain law of definite proportions or law of definite composition. This law was given by a French chemist Joseph Proust. He stated that a given compound always contains exactly the same proportion of elements by weight. Now see, source of a chemical compound may be natural or may be synthetic. Synthetic means you can prepare the compound in laboratory. Now I am illustrating this law with the example of carbon dioxide. This is carbon dioxide. Carbon dioxide you can prepare by the following methods. Number 1, by burning coke in the presence of oxygen. This is coke, oxygen plus oxygen, we are getting carbon dioxide. Or number 2 method, by the decomposition of calcium carbonate on heating. So this is calcium carbonate, this is heating symbol. We are getting calcium oxide and carbon dioxide. And by third method, by the action of dilute hydrochloric acid on washing soda. This is sodium carbonate or washing soda plus HCl. We are getting NaCl plus water plus carbon dioxide. Now, in each case, whatever carbon dioxide we are getting, it is having elements carbon and oxygen, and ratio or mass percentage of carbon and oxygen are same. You know, atomic mass of carbon is 12 and atomic mass of oxygen is 16. So, in carbon dioxide, carbon to oxygen ratio by mass is, atomic mass of carbon is 12 and carbon dioxide is having 2 oxygen atoms, so 16 to the 32. If you simplify, it is coming 3:8. So everywhere this ratio by mass of carbon and oxygen is present. So you can say that whatever be the source of a chemical compound, it always contains the same elements combined together in the same fixed proportion by mass. Proust worked with 2 samples of cupric carbonate. Cupric carbonate means copper is in +2 oxidation state. Copper is in +2 oxidation state and carbonate ion is this one. So cupric carbonate means this one. He took one natural sample and one synthetic sample, and he found that the percentage of elements present in both the samples was same. In cupric carbonate, elements copper, carbon and oxygen are present. And it was observed that percentage of copper in both the sample was 51.35. Percentage of carbon in both the sample was 9.74 and percentage of oxygen in both the sample was 38.91. It is given in NCERT book. To apply the law of definite proportions, the same isotopes of the elements in different samples have to be considered. As for example, in carbon dioxide, using carbon 12 isotope, the ratio of carbon to oxygen by mass is, here atomic mass of carbon is 12. So 12 and 2 oxygen atom is there. So 16 to the 32 means it is coming 3:8. And in carbon dioxide, using carbon 14 isotope, the ratio of carbon to oxygen by mass will be, carbon is here, atomic mass is 14. So 14 is to 16 to the 32 means, if you simplify, it is coming 7:16. So these ratios are not same. That means if you are having two samples of carbon dioxide, one is having carbon 12 isotope, another is having carbon 14 isotope. So these ratios, carbon to oxygen by mass ratios are not same in both the samples. So here law of definite proportions is not obeyed. So if someone will ask you in which case the law of definite proportions is not obeyed, you have to answer the law of definite proportions is not obeyed when the element exists in isotopic forms. Which cases the law of definite proportions is not obeyed? Answer will be the law of definite proportions is not obeyed when the element exists in isotopic forms. Now we will solve some problems. 3.244 grams of lead combined directly with 0.501 grams of oxygen to form lead peroxide. Lead peroxide can also be prepared by heating lead nitrate, and it was found that the percentage of oxygen present in lead peroxide is 13.38%. Use this data to illustrate the law of definite proportions. Now see what is given here. Here it is given that by two methods lead peroxide is prepared. In method number 1, lead is combined with oxygen to form lead peroxide. Now, amount of lead is given 3.244 grams and amount of oxygen is also given 0.501 grams. So if we add these two, we will get amount of lead peroxide. So 3.244 plus 0.501 grams is equal to, we are getting 3.745 grams. Now in another method, we are getting lead peroxide also. By another method we are getting it. Okay. And their percentage of oxygen is given. So from the first method also, whatever lead peroxide we are getting, their percentage of oxygen we can calculate. How you will calculate it? You can write 3.745 grams of lead peroxide contains 0.501 grams of oxygen. Percentage of oxygen we have to calculate. Therefore, 1 gram of lead peroxide contains 0.501 divided by this much grams of oxygen. Therefore, percentage we have to calculate. So, this much grams of lead peroxide contains 0.501 divided by this multiplied by 100. So point we can cancel. Here we are getting here 749. So By simplifying, we can write here, if we multiply these two and this, if we divide, we will get around this grams of oxygen. So therefore, in method number 1, whatever lead peroxide we are getting, in this lead peroxide, percentage of oxygen is what? 13.38%. And by method number 2, whatever lead peroxide we are getting, there also percentage of oxygen is this. You see, both are same. So lead peroxide is having elements lead and oxygen. So in both the cases, if percentage of oxygen is same, then percentage of lead will also be same. So we can say the law of definite proportion is illustrated here. It is given that 2.16 grams of metallic copper on reaction with nitric acid and subsequent ignition of the nitrate gave 2.7 grams of copper oxide. In another experiment, 1.15 grams of copper oxide on reduction yielded 0.92 grams of copper. Show that these observations are in agreement with law of definite proportions. How to solve this problem? Solution. So in first experiment, it is given metallic copper is reacted with nitric acid and whatever nitrate you are getting, ignition of that nitrate is giving copper oxide. Amount of metallic copper is given 2.16 grams and amount of copper oxide is given 2.70 grams. So in copper oxide, what elements are there? Only copper and oxygen. So you have to determine the amount of oxygen present in copper oxide. Okay. Therefore, weight of oxygen in copper oxide is equal to 2.70 minus 2.16. So here we are getting this much grams. Now in another experiment, it is given this much grams of copper oxide on reduction yielded this much grams of copper. Okay. So first what we have to do, we have to here determine the ratio of copper and oxygen by mass in copper oxide is what? Copper is how much? 2.16 grams, and oxygen, it is this much grams. So you have to simplify to get a simple ratio. Here we are getting 4:1. Now for second experiment, it is given copper oxide on reduction is giving metallic copper. So amount of copper oxide is given this much grams. Amount of copper is also given this much grams. So similarly, we can calculate weight of oxygen in copper oxide for second experiment. Therefore, weight of oxygen in copper oxide is how much? This much grams. If you calculate, we are getting this grams, 0.23 grams. Similarly, here also we have to calculate the ratio of copper and oxygen by mass in copper oxide is how much? Amount of copper is 0.92 here grams, and amount of oxygen is this. So we have to simplify this one. If we simplify, means both sides if you divide, you have to divide with 0.23, you will get 4:1. So in first experiment, the ratio of copper and oxygen by mass you are getting 4:1, and here also same thing, you are getting 4:1. Therefore, these observations are in agreement with law of definite proportions. Clear? Now problem number 3. It is given in copper sulfate crystal there is 25.45% copper and 36.07% water. If the law of definite proportions is true, find out the weight of copper required to get 20 grams of copper sulfate crystal. Now you see, since the law of definite proportions is true, the percentage of elements present in any copper sulfate crystal must be the same. So it is given percentage of copper. So we can write 100 grams copper sulfate crystal this is solution, okay. Copper sulfate crystal contain copper 25.45 grams. Therefore, unitary methods, 1 gram copper sulfate crystal contains copper how much? This much grams. Therefore, how much it is given? 20 grams. 20 grams Copper sulfate crystal contain copper 25.45 multiplied by 20 divided by 100, this much grams. If we multiply these two, we are getting so answer is this much grams. It is given 0.16 grams of sulfur on burning in air produced 112 ml of sulfur dioxide at NTP. Sulfur dioxide obtained by the decomposition of a sulfate contains 50% of sulfur. Illustrates the law of definite proportions from the data given. So how we will solve this problem? So it is given sulfur by the treatment of oxygen, it is producing sulfur dioxide. You can see it is balanced chemical equation. 1 mole of sulfur is reacting with 1 mole of oxygen to produce 1 mole of sulfur dioxide. So it is given 0.16 grams of sulfur, it is given, is producing 112 ml of sulfur dioxide. Weight is not given here for sulfur dioxide, volume is given at NTP. NTP means normal temperature and pressure. So what we have to do? You know, at NTP, volume of 1 mole sulfur dioxide, it is gas, is 22,400 ml. Okay. Now you know molar mass of sulfur dioxide is what? Atomic mass of sulfur is 32. Atomic mass of oxygen is 16. 2 atoms are there, oxygen atoms, so 16 to the 32. So molar mass here total it is coming 64 grams, right? Now what we have to do? At NTP, weight of this much ml of sulfur dioxide is what? 64 grams, because I told you already at NTP volume of 1 mole of sulfur dioxide is this. So 1 mole means its weight is 64 grams. Therefore at NTP weight of 1 ml of sulfur dioxide is 64 by this at this much grams. Therefore what is given? This much volume is given at NTP, weight of this much ml of sulfur dioxide is equal to 64 into this divided by this much grams. So here we are getting if you calculate, it is coming, simplify, this is coming this much grams. Now you see So here weight is coming, how much? Weight of sulfur dioxide is coming 0.32 grams. So in 0.32 grams sulfur dioxide, how much sulfur is present? 0.16 grams. Therefore, in first case, what's the percentage of sulfur? Percentage of sulfur is equal to amount of sulfur by total amount of sulfur dioxide into 100. So we are getting 50%. And if sulfur is present in 50% amount, then oxygen is also present in 50% amount. And in the second experiment, sulfur dioxide obtained by the decomposition of sulfate contains 50% of sulfur. Here also it is coming, amount of sulfur or percentage of sulfur is 50%. Here also it is percentage is 50%. So the percentage of sulfur and oxygen in both the experiment is same. This illustrates the law of definite proportions. Today till this. In next video I will explain law of multiple proportions. If you like this video, please like, share and subscribe it. Thank you.